Alright, we are going to talk about simple machines, or just machines in general at first. So what is a machine? A machine is a device that makes doing work easier. Machines typically take energy or effort in order for them to actually work efficiently, and machines work easier by increasing the force. So the more force there is, the more the machine is able to do, the more work the machine is able to do. If you remember when we worked on calculating work and power, that would make sense. They are related, the force and the amount of work, and the amount of energy that is required. So input of force and output of force. So machines work with two forces. The input force, which is the effort, is the force that you apply to the machine. And then there's the output force, or the load. And this is the force the machine applies to what you are trying to move. So the input force is going to balance out with that output force. Okay? So what is a simple machine? And this is really what we're going to work with in here, is simple machines. Simple machines are machines that do work with only one movement of the machine, made with few or no moving parts, almost no moving parts. So this isn't like a lawnmower or a car or anything. This is truly a simple machine with no moving parts really, and it just does one movement to do one activity. So some examples of simple machines are like levers, pulleys, wheels and axles, inclined planes, like that means like a little tilted hill, screws or wedges. So we'll talk about each of them now. So a lever. A lever is a bar that is free to pivot around a fixed point. So this is almost like a scale. Okay, so we have the fulcrum, which is the middle part, and you'll notice the force. So if I push up here, the load will go down here. The fulcrum is between the input force, effort, and the output force. So if it's a first class lever, that means the fulcrum is balanced in between the input and the output. And scissors are a good example of that, because the fulcrum, or the balance point, is found right in the middle. You push down on the handles and it makes the load cut. Okay, it moves it. A second class lever, or output force load, is between the fulcrum and the input force. So basically the fulcrum here is here, the force that you're going to apply is here, and then the load is right here. So when you push, okay, you pull a force here, the load is pushing down and you're able to push forward. So that is the second class lever system. And then the third one is the input force, or effort. Okay, and that is between the fulcrum and the output force. So notice we went load, fulcrum, force, fulcrum, load, force, and now we're going fulcrum, force, load. So the fulcrum is still on the side, it attaches them together. The force is going to be pushing up, and the load is going to be pushing down. So you will be pushing up, you push, let's say this is the stapler, you're going to push the bottom of the stapler up, and then the load is going to actually push down the staple to create the staple effect. So understand that those different classes of levers are what actually do work. And those are simple machines. Okay, those are all examples of simple machines. The second one we're going to talk about is pulleys. Pulleys is just a grooved wheel with a rope and a chain or cable running along a groove. And you guys use this when we did our tracks. Okay, so the load is some sort of weight, and you are pulling down in order to lift that weight. So this machine is helping you lift using the force that you apply to the rope to apply that same force to the load that is carried on the other side of the pulley. Wheel and axle. So wheel and axle consists of an axle attached to the center of a large wheel so that the wheel and the axle rotate together. So the axle is just a little rod through the center of holes. So this almost looks like one of those little, like, let's see if I can find one. I don't think I have anyone, but one of those little things we used as weights a couple of times in here. Here it is. Okay, so it looks kind of like that, and then if I were to put a rod through here and then use that in order to spin something, that would be a wheel and axle simple machine. And basically an example of that would be like a simple machine is definitely a Ferris wheel. Okay, so all you have to do is turn the axle and it will turn the wheel, and that does work. Inclined plane. So this is just a sloping surface such as a ramp that reduces the amount of force required to do work. So basically, when you're unloading a truck, it's easier to go down than it is to go up or to even go straight. So this inclined plane allows us to use less work in order to do work. So objects are easier to push than to lift straight up. So when I'm using a ramp, let's say I have to go up that ramp instead of down that ramp, it's a lot easier to push the force up this ramp than it would be to lift it from being right here to being right here so that it can get into the truck or get into where it's going. So these allow us, inclined planes allow us to make the amount of work necessary to put the load where it needs to go than it would be to just pick the load directly up and put it where it needs to go. So we're able to slide it easier. The screw. So the screw is an inclined plane wrapped in a spiral around a cylindrical post. That is a really complex way of saying it looks like a screw. Okay, so you have the head and it has some sort of notch in it so that you can twist it. And then it is a cylinder that is wrapped with a kind of spiral-like metal, or maybe non-metal, but some sort of spiral-like thing so that when it screws in, it doesn't back out. The wedge. The wedge is an inclined plane with two or more sloping sides. Now, the easiest way to describe this is like an axe or anything that's sharp, a knife, where we have basically a wedge, okay, so a sharp edge here and two sides right here, and when I input force here, so when I push down on that, the output force goes there and this wedge will split whatever is underneath it. So a compound machine is made up of two or more simple machines that operate together. So here you may notice that we have a wheel and axle, okay, and you may notice that we have a couple of other of our compound machines that we discussed kind of here. So I'd like you really quick to try to think of what the compound machines are, or what the simple machines are that make up this compound machine that is a bicycle. Okay, so simple versus compound. So a simple machine is made with few or no moving parts. Examples are wagon wheels, seesaws, or just a regular saw like you would use to cut. A compound machine is made up of two or more simple machines. Example would be scissors, is lever and wedge, wheelbarrow is wheel and lever, drill is wheel, screw, and wedge. Machines make work easier and can use force to cause motion. So it's usually a force that you apply to it. So again, these machines that we're specifically talking about are not necessarily like engines. They don't have engines in them. Okay, a force is applied to them by us, and that force is driven into the load so that something can happen to that load. So I hope that makes sense. Please write down any questions you have. Thanks.